Section 1.1, we're going to learn about what are called linear equations. When we're talking about linear equations, linear, if you remember back to our chart that we made about polynomials, linear just means the highest power of x is 1, so x to the first. There are quadratic equations with the highest power of x being 2, cubic where x is 3, but for this section we'll just be talking about equations with the highest power of x as 1. So let's take a look at some examples and let's solve, let's say 3 times 2x minus 4 is equal to 7 minus x plus 5. Alright, so just kind of taking a look at the equation first. If you remember, we talked about PEMDAS, and we said when we want to simplify an expression, remember an expression doesn't have an equal sign, we go this way. If we want to solve an equation, once we get all the x's on one side, we'll go this way. So let's start off. When we see parentheses, first thing we could do is get rid of them by distributing. And if there's no number in front, we could put a 1 there and distribute that. So 3 times 2, we get 6x minus 12 is equal to 7 minus 1x minus 5. Combine our like terms. 7 minus 5 is 2. Let's get all the x's on one side. What solve means isolate the variable. That's what it actually means to solve. Isolate just means get it by itself. So let's get all the x's on one side, and let's get all the numbers on the other side. We get 7x is equal to 14, and if we divide by 7, we get that x is 2. That's how we would solve a problem like that. Now what we did is we added and subtracted the 12, right? So we added and subtracted to get everything on one side. So that's working up the ladder over here. And then the next step after we added and subtracted is we multiplied and divided to come up with x is equal to 2. So you could, hopefully that explains how that works. Let's move on to our second problem. It says 2x plus 4 all divided by 3 plus 1 over 2x is equal to 1 over 4x minus 7/3. Alright, now there are a few different ways we could do this. One thing we could do is we can get a common denominator, combine fractions, and then maybe cross multiply. One thing that my students usually prefer to do is that we figure out what the least common denominator is, and then what we do is we multiply that least common denominator times all of the fractions. What that'll wind up doing is eliminating all of the fractions, and most people prefer just to get rid of fractions and work with integers. So between 3, 2, 4, and 3, we could even factor the 4. 4 is really just 2 times 2. So in our least common denominator, we definitely need a 3. We definitely needed one factor of 2. And we definitely need another factor of 2. So our least common denominator would be 12. If we multiply everything by 12, it'll get rid of our fractions. One other thing that'll work too is you don't need to use 12. You could use like 24. I mean, really what some people do is they just multiply all the denominators together. So like 3 times 2 is 6, 6 times 4 is 24, 24 times 3 is 72. You'd get the same answer, but if you use the least common denominator, you'd be working with the smallest possible numbers. So if we multiply everything by the least common denominator, we're multiplying by 12 and dividing by 3. So 12 divided by 3 is 4. Really, this part just turns into 4 times 2x plus 4. Instead of multiplying by 12 and dividing by 3, just multiply by 12 divided by 3. Over here, we're multiplying by 12 and dividing by 2, so just multiply by 6. Here, we are multiplying by 12, dividing by 4, that just turns into 3. And here, multiplying by 12, dividing by 3 just turns into 4. So now let's clean things up. It goes into 12. 4, that's where that came from. That's where the 6 came from. So we'll distribute. This will be 8x plus 16 plus 6x is equal to 3x minus 28. Combine our like terms. And now it's pretty straightforward. Let's get our variables on one side, the numbers or the constants on the other. And x would be negative 42 over 11. I think I did that right. 28 and 16 is, oh, that's 44. Oops. And negative 44 divided by 11 would be negative 4, right? So, not a big deal. Something else we could have done, and you don't have to know the second technique, I just like showing alternate ways. Say if we had 2x plus 4 over 3 plus 1/2 x is equal to 1/4 x minus 7/3. One thing that people do is they get a common denominator on each side. So on the left side it would be 6. We'd multiply top and bottom here by 2, top and bottom here by 3. So when we combine them, 2 times 2x plus 4 plus 3x over 6, we can write them all as just one fraction, is equal to, this would be 3x over 12 minus 28 over 12. So we could put those together. And then cross multiply to finish things up here, just like we are solving a proportion. When we solve a proportion, that's when two fractions are equal to each other. We use cross multiplication. Set that equal to 12 times 2 times 2x plus 4 plus 3x. All right, so let's finish this up. This would be 18x minus 6 times 28 is 168 is equal to 12 times, this would be 4x plus 8. Now we have the 3x. So finish up here. This would be 48x plus 12 times 8 is 96. Plus 12 times 3 is 36x. Let's combine our like terms on each side. 48 plus 36 is 84. And we can get all of our x's on one side. And our constants on the other. And if we divide both sides by negative 66, you can see that x would equal negative 4. So, I mean, we do get the same answer. I think the first way would be best. If looking at rational expressions, if you could just eliminate the denominators, I think that's a better approach than getting a common denominator and cross multiplying, although you do get the same answer. All right, so now let's talk about different types of equations. One type of equation is called a conditional equation. Now, a conditional equation is what we're used to, like what we just did here, where we get x is equal to one number, like x is equal to -4. If there's one solution, that type of equation is called a conditional equation. Now, we do get some like funky answers too. One type is called an identity. An identity happens when you go to solve the equation. You might get like 0 is equal to 0. What that means is both sides are exactly equal to each other. In this case, the appropriate answer we would write would be all real numbers. I talked about different types of numbers. In this case, you could put in any real number and both sides of the equation would be the same. The last type of an equation is called a contraction. And with a contraction, what would happen would be, if you go to solve it and the x's go away, but both sides are not equal to each other. In this case, this just means that there's no real solution, which means no real number makes the equation both halves equal to each other, and there's just no solution. So let's take a look at some examples of these. The directions are just going to be to solve. And let's say we had -2 times x plus 4 plus 3x is equal to x minus 8. Solving it like we usually do, let's distribute and combine like terms. -2x minus 8 plus 3x is equal to x minus 8. Combine our like terms. X minus 8 is equal to x minus 8. I mean, at this point, we see both sides are equal to each other, so it's an identity. But if we were to add 8 to both sides and subtract x to both sides, you could see you do get 0 is equal to 0, which means that this would be an example of an identity. You could just say identity if you want. You could say all real numbers if you want to. I'd accept either answer. Another example like this would be 3 times 3x minus 1 is equal to 9x plus 7. Now in this case, if we distribute, we get 9x minus 3 is equal to 9x plus 7. Subtract 9x on both sides. And we get -3 is equal to 7. We could add 3, but bottom line is the x's are gone, and we have one number which is clearly not equal to another number. We would call this a contraction, or you could even just tell me at this point that there's no solution. I'll accept either of these. Generally, people just write no solution. And then the last thing I wanted to talk about in this section was how to solve a literal equation. Really what this is like is if we have a formula, sometimes we just want to get one variable by itself. So for example, if we take simple interest, the directions would be to solve for the identified variable. So like if we had simple interest, where interest is equal to the principal times a rate and time, and we want to solve for t. That's how it would be written. Well, if we want to get t by itself, we need to do the inverse operation to make that happen. So if we want to get t by itself, we have to get rid of multiplying by p and r. The inverse operation would just be dividing by p and r. Then you just get t by itself, and it's equal to the interest divided by the principal times the rate. That's what we mean by solving literal equations. One more. What if the formula looked like this, where the amount in the account minus the principal is equal to p RT, and we want to get p by itself. Well, if we want to get p by itself, we could start by getting it on the same side. So I'm going to add p to both sides. and we get A is equal to P RT plus P. Well, we have two terms with P in it. So the most important thing in math is factor. We could actually take out a GCF of P. What that means is just divide P out of both of those terms. Cancel here. P divided by itself is just 1. And then if we want to get P by itself, instead of multiplying by the quantity RT plus 1, if we divide both sides by the quantity RT plus 1, it would cancel out here, and it shows up on this side. So bottom line is you would get P is equal to A divided by RT plus 1. That would be our answer.